Hello everyone, myself Anil Sharma from Impulse Technology. In this video, I will show you how to model and simulate organic light emitting diode using Setfos software. Let's get started. First of all, I open this Setfos 5.2. I click on it and click Run as Administrator to provide a background privileges, permissions. It is loading the module and example and checking the license. On the top of the screen, you can find some new features window. Whatever new updates, new features added in current or upcoming version, that will display on the top of the screen. You can check all features by clicking on next button, and you can close this window so that you can check background main window. Now in this video we will go through a step-by-step simulation of fully functional organic light emitting diode. So I would like to click on file options so that if you want to take help, we have a manual and tutorial to check the background physics equations, model equation that is explained in the manual page, and step by steps how you can model the OLED in a PDF format. It is also given in the tutorial. I want to make a new project here, so I click on file option and click on new button, and I can create a button and activate this drift diffusion module by clicking on this battery sign, and I will add two layers in between surrounding and substrate. Now I will fill in the layer name and thickness by selecting the corresponding field. So I will define the gold on the top, and next I can define MEH minus PPV, and then I can take it calcium, and I can set the thickness gold equal to 10 nanometer and MEH PPV equal to 120 nanometer, and this is again calcium 10 nanometer, and this is substrate. Now I can activate this MEH PPV as a semiconducting layer. So I go to this general option and select as a semiconducting, because we have to define the electrical semiconducting property of this layer. Now to set the electrical property of this layer, I will just hide this layer stack tab so that visualize my screen properly, and go to the semiconducting tab. Either I can define my property, user can define their property here in these options, where charge, exciton, traps, mobile ions, multiple tabs are there. You can define your own property in these tabs. I want to import the property, electrical property of this layer. So I will click on it and find this mehppv.em file, electrical material file, and click on open it. Now I will set the gold and calcium layer as an electrode. So I click on this gold and click on general and set as electrode. Similarly, I can click on this calcium and set as electrode. Now I can define the work functions, or I can type electrode type, it's a thermionic, and I can set the work function. For calcium layer, that is 3.3, and for gold layer I can click on it and select as a thermionic type because I want to include the ionic excitons and define the work functions. The energy level diagram display to choose the HOMO-LUMO levels for the MEH PPB material and the corresponding work function for both the electrode. This is energy levels. Now to simulate the pulse current operation in drift diffusion settings, I will enable the transients modes by clicking on it and activate steady state pre-calculation. If it is not activated, this will ensure that the transient operation starts from an equilibrium condition of device. In the general tab, I have to define the voltage. Suppose I want to apply 4 volt, so I will mention 4 volt here on top electrode. And this is a temperature that already mentioned. Now in this transient mode, I will set a total simulation time. Suppose I want to define 300 microsecond. So we can define that 300 microsecond accordingly. Furthermore, define a voltage pulse that rise from 0 to 4 volts. So I enable this voltage pulse transients and define the time offset. So I activate this enable transients voltage and pulse widths I can define 100 microsecond and voltage is already defined, and I can check this initial voltage as well. I can hide this layer stack tab. You can check the transient preview for this voltage. Now I can go to this transient solver tab to define the numerical setting. Here I can select the transient solver method. So I select this Euler method with a constant time steps of 1 nanoseconds. And I can check this export transients and export transient nth iteration. I can mention 10. And this constant I can define 1 as a transient solver setting, nanoseconds. Now we are ready to start the simulation. For that I can change this name of my OLED. Now I will click on run button to start the simulation. After few seconds the results will appear. Simulation is running, drift diffusion completed, transients is running. Simulation is very fast. It run the calculation within 2, 4 or 5 minutes maximum, dependent on your structures. Now I can click on current transients among various results. I can also zoom it. Now to check the current voltage curve in the Setfos, in the drift diffusion tab in layer stack, I can go to this, select this steady state to find the current voltage curve. Here I can select the steady state current continuity solver parameters. Now if you want to sweep the parameter, I can click on this, enable the sweep mode to sweep the value from one range to another range. To sweep over applied voltage range, I have activated it. Now a voltage can be defined in this picture. So I will go to it and select the voltage parameter, and I can define the voltage range from 2 volt to 10 volt. And I can define the step size 0.1, and unit is already defined in volt. Now I can run the calculations. I click here to enable this run button and click on it. Now I can click on this current. You can see this is a current voltage plot. Red one is called mean currents. Now overlapping blue one is called anode current, and overlapping green one is called cathode current, and bottom side it is called recombination current. Now to perform the electronic to optical simulation, so we have to solve the depth diffusion equation and to calculate the exciton distribution as an emission source for the optical light out coupling. For optical coupling, the emission module must need to be activated additionally. So I click on this bulb sign to activate this module again. To calculate the light out coupling, we must specify the refractive index of the material. So I just go to this layer structure tab and click on this gold and import the refractive index. Choose the file option. Here I can import from my database. User can also define new refractive index in our database as well. So I select this au.nk. Now I go to this mehppb and select this nk file from our directory. I have selected it and click on open. And similarly I click on calcium and select file and click on open it. Calcium.nk. It's now selected. The corresponding is air with a constant refractive index of 1 and substrate glass with a constant refractive index of 1.5. Now we will define this MEH minus PPB layer as a light emitting layer. So I go to this general tab and set as emitter. By activating this emitter option in the layer general layer properties. Now go to this emitter setting and import the luminance file. I click on choose the file and this is photoluminance file that I can pick up and click on open from the material database. Now finally it is enable the coupling between the excitons and dipoles. Now select the distributions and select exciton coupled and define exciton 1 from this drop down. Now this tells Setfos to calculate the exciton distribution as a source for the dipole. All the exciton parameter like diffusion constant, radiative decay rate, etc. should be defined in this electrical material.em file. In this case, they can be found in MEH PPB file that we have already imported. Now I will go to the strip diffusion setting tab and activate the exciton tabs. That is now activated in the general setting to calculate the excitons. Now to start the simulations, I simply click on this press and I can define the new name of my projects and click on start. Now calculation is done. You can find all parameter, IV curve, internal quantum efficiency, power density and other electrical profiles, Venn diagram, charge density plot, recombination on multiple voltage, Vicing, potential on different voltage, as well as some emission property like CIE color diagrams. You can plot and other luminous efficiency and current efficiency plot, luminance plots, peak emission intensity, radiance with S polarized and P polarized, and optoelectrical device efficiency and EQE, external quantum efficiency, Lambertian, and spectral analysis. I want to show you the main one that is called emission. This is emission on different voltage Vicing. Once you change this Vicing, how this emission will be changed with respect to voltage. You can check in the form of curve or in the form of checkboard. This is emission in this region. If you require more information, kindly contact to Impulse Technology. Thank you very much for watching this video.